Hey everyone, welcome back to Chem Story. Today, we're going to talk about how carbon and hydrogen atoms are classified in alkanes. It might seem like a small detail, but it actually plays a big role in understanding organic molecules. So let's break it down and see how it all works. In alkanes, we classify carbon atoms based on how many other carbon atoms they're directly bonded to. If it's bonded to just one carbon, we call it a primary carbon, or 1 degree. If it's bonded to 2, that's a secondary carbon. 3 bonds, that's a tertiary carbon. And if it's bonded to 4 other carbon atoms, that makes it a quaternary carbon. Pretty straightforward, right? Once you get used to it, recognizing them becomes second nature. Let's take a real example. 2,2,3-trimethylpentane. Here, we've shown the molecule in 2 different ways, one as a Lewis structure and the other as a skeletal structure. But no matter which one you're looking at, the way we classify the carbon atoms doesn't change. This molecule actually has several different types of carbon atoms, so let's break it down and take a closer look. Let's start with the 5-terminal CH3 groups, the ones at the ends of the branches. Each of these is bonded to just one other carbon, so they're all classified as primary carbons. Now the carbons at positions 2 and 3 are a bit more substituted. Both of the carbon atoms at position 2 are bonded to 4 other carbons, so they're quaternary. The carbon at position 3 is bonded to 3 carbons, which makes it tertiary, and the one at position 4? It's bonded to just 2 other carbons, so it's a secondary carbon. We can also classify hydrogen atoms, and it all depends on the type of carbon they're attached to. If a hydrogen is bonded to a primary carbon, we call it a primary hydrogen. If it's attached to a secondary carbon, it's a secondary hydrogen, and if it's on a tertiary carbon, that makes it a tertiary hydrogen. Now, here's the thing. Quaternary carbons don't have any hydrogen atoms, so technically, there's no such thing as a quaternary hydrogen. Pretty straightforward, right? Now, let's go back to 2,2,3-trimethylpentane and take a look at the hydrogen atoms. In a skeletal structure, the hydrogens bonded to carbon aren't drawn out, they're just implied. But remember, each carbon needs to form 4 bonds. So based on how many bonds are already shown, you can figure out how many hydrogens are missing. Hydrogens that are attached to primary carbons are called primary hydrogens. Now in this molecule, we've got 5 primary carbon atoms, and each one has 3 hydrogens. So if you do the math, that gives us a total of 15 primary hydrogens. Hydrogens attached to the secondary carbon, that's carbon number 4, are called secondary hydrogens. Since that carbon has 2 hydrogens, we've got 2 secondary hydrogens in this molecule. And finally, the one hydrogen that's bonded to the tertiary carbon at position 3, that one's a tertiary hydrogen. So next time you look at an alkane, try classifying the carbon and hydrogen atoms yourself. It's a small step, but super helpful, especially when you start learning about reactions like halogenation. And that's a wrap. Now you know how to classify carbon and hydrogen atoms in alkanes. Thanks for watching, and I'll see you in the next one.